This screencast will introduce you to the physics ideas of position, displacement, and distance. The topic or learning target is I can compare position, displacement, and distance. And the essential question is how do position, displacement, and distance compare and contrast? So let's begin with position, the first vocabulary word. Position is an object's location or how far it is from another object or a zero mark, say on a number line. The symbol for position is an X, and we typically measure it in meters because that's the standard international unit. However, we can sometimes use centimeters as well. The key to remember about position, as well as displacement, is that it's relative. So if we look at this picture that shows the sink, the camera, and the plant, the camera doesn't move. However, we can describe it in two different ways. We can describe it as being 5 meters to the right of the sink, or we can describe it as being 7 meters to the left of the plant. It hasn't moved. We've simply described it a little bit differently. We've described it relative to different objects, the sink and the plant. So remember, the symbol is an X, and a way to remember that is X marks the spot, position, location, or place. Displacement is how position changes. So displacement is the change in position of an object, so it only occurs when something moves. The symbol for displacement is called delta X. This symbol right here is called delta X, the triangle X. It's not described as a triangle. It looks like a triangle, but you pronounce it as being delta X or change in X. The unit for displacement is a meter, and we can occasionally use centimeters as well. So the equation for displacement is final position minus initial position, and the equation there is shown as delta X or displacement is equal to X sub F minus X sub I. Notice that the subscript F on the first X term in the equation stands for final, and the subscript I on the second part of the subtraction stands for initial. We will have algebraic signs that tell us important things about displacement. When displacement is positive, that means that the object has moved to the right. When displacement is negative, that means the object is moving to the left. That's a convention we will use in our class, that right is positive and left is negative. And it's important to bear in mind that displacement can be both positive and negative. So how do we calculate displacement? So we need to identify the initial and final positions and then insert it into the displacement equation. So notice that we have a football player. His initial position is 10 meters. He moves to a position of 35 meters. So his displacement will be the difference between those numbers. So his displacement will be 35 meters minus 10 meters, meaning that he has a displacement of 25 meters, a displacement of positive 25 meters. All right, let's try another one. So we've got the football player across the top who has a positive displacement of 25 meters. Let's look at the ladybug at the bottom. The starting position for the ladybug is a positive 4 meters, and that ladybug is going to move toward the left, and the ladybug's final position is 1 meter. So when we drop those values into the equation, we take the final position 1 and subtract from that the initial position 4 and find out that the ladybug had a displacement of negative 3 meters. So that's interesting. The ladybug's final position was still positive. The ladybug's stopped at a position of 1 meter. However, her displacement was negative 3 meters because she had moved toward the left. So to kind of summarize that, example 1 is an example of something that moves toward the right and has a positive displacement. Example 2 is an example of something that moves toward the left and has a negative displacement. Now let's recall for a moment that even though the value next to delta x equals 25 meters doesn't include a positive sign, we remember that When there is no negative sign in front of a number, we assume that value to be positive. So next, let's talk about distance. Distance in physics is the total length of the path traveled. So it's how far something moved altogether. And the symbol for it is a lowercase d. Our SI units for it will be meters, m, and the other units will be centimeters as well. The equation will be total distance is equal to distance 1 plus distance 2 plus distance 3, or as many chunks as you need to cover the whole distance that an object moved. A key thing about distance that makes it different than displacement is that distance is always positive. If you look at the picture shown, we can see that there's a red dotted line. That shows a distance covered of something that moves from the barn to the house that could take kind of a curly pattern and not go straight there. However, the displacement will be a straight line shown by the blue one. And I apologize, but because it appears that displacement is misspelled. There's an extra N in it. Sorry about that. So back to business. How do we calculate the total distance an object moves? Well, in this example, we'll go back to the football player. So the football player starts at 10 meters, moves 20 meters in one direction. Sorry, my dog's upset. Turns around and goes back 10 more meters in the other direction. So the football player moved 20 meters, then 10 meters. So the overall distance moved by the football player was 30 meters. So distance in this case was 30 meters. So to summarize, we talked about position, distance, and displacement. Right is positive, left is negative. Position is given by an x, and it's always the location of an object compared to something else. Typically, that something else is a number line. Distance is given by the variable d, and it depends on the path that's taken, how far an object moved along a path. And displacement is just the difference between the initial and final positions of an object. So now you can move ahead in our Canvas course and complete vocabulary bookmarks for position, distance, and displacement.